Okay, here I have a little electronics kit off eBay. It's like $4 or $5, including postage from China, so I thought it'd be worth a try, even just as a little thing to practice soldering on. It's one of these little 4017 IC chasers, LED chasers. Not sure, this one's got a bunch of blue and a bunch of red LEDs, so I'm not sure if it does both or you can choose your colours. So it's basically just a little 555 timer chip and then a 4017 decade counter. And I noticed this one, it's a CMOS chip. It's just in a what looks like a standard plastic bag with no static, reducing foam or anything like that. Some of the pins look a bit bent as well, which is another annoying reason not to have your IC just sitting in a packet when you put it in an envelope type thing. I don't think it was even a padded bag, just a cardboard envelope, I think. So, be interesting to have a play with this and see if that chip's still any good. I don't know, this could be an anti-static bag, you never know. They're usually pink or silvered or something, so I might pull that out. I've got a bit of some old chips here, or new chips that are old stock. And a couple of LM3914 LED drivers and a couple of other bits, but anyway, I'll use this foam to put that chip in when I get it out of the bag, because you don't want you get static on those. Looks like this label's holding it shut. We'll see what's actually in here. Got a circuit board and some instructions. See if we can get our little CMOS chip out there. And I've got some pliers here somewhere. I never used to have much luck with these as a kid. CMOS chips, if I so much as looked at them the wrong way, I would end up popping the things. I did end up getting a chip holder thing, which is what I should be using for this. It shorts all the pins together and inserts it in the board. I'll have to see if I can find that. I think I've still got it somewhere, so I'll put that in some static. Yeah, CD4017. And a bunch of other bits and pieces here. There's probably not a lot in it besides 555. At least the pins are reasonably straight on that, and then they're a bit bent. That's only a little linear chip, so that doesn't care much. Some diodes, resistors, bit of wire, potentiometer, so it must be speed adjustable, I assume. A couple of transistors, so there's 2 transistors. It might mean there's 2 bays of LEDs. There's even a little ceramic capacitor there, and 1 electro. It's a fairly basic little circuit that has the, I guess you'd need an electro for the time constant on the 555. That's our circuit. Yeah, so there's two sets of LEDs. Oh, they're in strings. 1, 2, 3, 4, 5, 6, 7 strings. What have they done here though? They've only got 2 transistors. So this isn't a chaser. Oh yes, I reckon what they've done, it's not going to chase in the normal way. If they made them on alternate outputs or something, that's what the diodes do. You've got 3 diodes feed 1 transistor, 3 feed the other. But one's got 4 strings and one's got, oh wait, one's got 4 strings of 3 LEDs. Oh, I wonder if, no, they're not joined together. They're only, oh, that's joined to ground. That's joined to ground as well. So they're switching the LEDs to deck. We've got 3 strings of 4 LEDs and 4 strings of 3 LEDs. I'm not sure if it matters which LEDs go where. It's going to be the same number of each, I guess, isn't it? 12 of each. 10k resistor in the base. 100 ohm resistor to the LED, so they're each through a 100 ohm string, 100 ohm series resistor. All strings come off that. Then of course we've got our 555 with a 10k capacitor and trim pot as the time constant, and then that little, can't remember what the other cap is for, the little ceramic capacitor. See, it's been a long time since I looked at a 555, so I can't remember what that is, but anyway, it's a reasonably thick circuit board at least. It looks like you can break the LEDs off the little displays, but of course the problem with these things on eBay is they don't actually show you what they look like running, they just show you a picture of a kit. when you see a 555 and a 4017, you assume it's just a standard chaser. But of course, being made in China, it's not going to be the case, I don't think. 2021-01, so it's fairly recently made. I'll put that other chip in there too so I don't bend the pins. So normally what I do is solder all these parts in and then put the chips in last. So these are actually quite good little practice things if you want to learn soldering. They're quite fine. And yeah, quite a few parts to put on here. So it looks like that little dude. You can see a little capacitor symbol there, but it's unpolarized. So that'll be our ceramic. I guess I should do the convention. The thing always used to be to make all the components, if you want to be really neat, make it so you can read all the components from one end and side of the board, so all the resistors, there's only two in this, but you make them so the gold band or tolerance band face the same way. You make it so the capacitors, or at least the ones you can do, all face the same way. We've got a little electrode there with its positive, which should be the long lead. Always best to check, I guess. Yep. And you can spread those legs out a little bit, they're pretty tight anyway. I mean, in theory I probably should put the lower parts in first, but I'm not really fussed about that. It's a quite nicely made circuit board by the look of it. See if the tinning's any good. Yes, very good. That's doing the job. So you put your soldering iron onto both parts, the pad and the lead. Get a little bit of heat in there and then apply the solder. That's probably the biggest art form to learn when you... What have I done with my good side cutters? They've gone somewhere after use these crappy old ones. Yeah, one of the things to learn with soldering is just really the art of getting that soldering tip to sit. I say try and just get on that little pad as well as the lead. And you only need it for a second, because obviously semiconductors and stuff, you don't want to be on there any longer than you need to be, because the heat will conduct up the leads. But eventually you get the hang of just touch and solder. Just make contact in the right way to both parts. Like I said, the actual part you're soldering to the board, plus the, they look like I'm guessing they're 100 ohms. I almost forget how to read these 5-band resistors. Okay, I've now got all the resistors and diodes poked into the board and got just the leads spread out a little bit. They're quite tight fit, these diodes anyway, almost a bit too close together, the holes on this thing, because you have to bend them quite close to the case, which normally you should try and bend them a little bit away from the case rather than too close. Normally I think these 1N914 type diodes, I used to make them as wide, the holes as spaced as wide as a resistor, but they haven't on this. So a couple of those are sitting up a little bit. I'm not going to bend them too much closer. But now we've got all those in place, so you just spread your leads a little bit so nothing can fall back. And you can turn the board upside down. Got a lot of pigtails sticking up in the air there. And again, just a matter of getting in, and you only need to give it the slightest bit of... I'll see if I can do a better close-up of this. Actually, I've got the transistors in there too, I forgot to put those in. And you just, yeah, put your, this is like a little chisel, not a completely conical tip, it's got little chisel faces on it, little flat faces on it. This is one of the fine Hacko tips, and it's just a matter of, yeah, you have a little bit of solder on there already tinned, but you just got to touch the pad. I sort of have the chisel face facing to the lead, so basically the side of the chisel almost right on the tip of the soldering iron, part of the more conical bit, lands on the actual pad on the board, which is hard to do, these are so small. But you just get a little bit of heat in it from that, so you're touching the circuit board pad, and also the flat part of the chisel just comes into contact with the component lead itself. And then you should only just have to just there for a small amount of time and just push your solder in while holding the soldering iron still, and then you can take it straight off again. The solder should flow beautifully around that. Again, one of the reasons to have these leads bent a bit is you don't want the component to be able to move at all, because if that component moves as you withdraw the soldering iron or anything, or move the board a little bit, if it wobbles at all, you'll get a dry solder joint, or a fair chance you will, because it'll move while the solder is setting. which will basically break the joint. Now, and again, I'm actually going to put the end of the tip, I can put the end of the tip down on the solder pad. So I'm actually making contact with the, well, it's tinned copper of course, but the copper pad there, which is silver in this case, and then just sort of touch it so it's right in the face of it's touching the lead. The end of the tip is butting onto the pad, and again just need a microsecond of time so that touches, a little bit of heat starts transferring, then you just go in with your solder and it should just flow around the joint perfectly. And so you're not putting any heat in there for long, any excess heat, because when you get to things like these transistors and even these diodes are somewhat heat sensitive. So that's a diode, we should be able to just go in and do these joints. That one did move a little bit, which is not a good sign. Now I've got that transistor in the way, I shouldn't have really put so many things on the board at once. But you can just go down. Sometimes you have to tilt the tip a little bit like I did there because I didn't have it quite right, until you see that solder flow around the pad. And yeah, it's a bit, because there's so much stuff here, the solder's having trouble getting through all the things sticking up in there, all the leads. And just check everything, it's easy to miss one, and it's also easy to not get one quite right. So if you spot anything, any part of the hole still, you know that you haven't got your solder to flow right around the pad. But you can do them fairly quickly like that. If you don't have so many leads sticking up, you can go even quicker. So again, like I can put the tip on the end there. Sometimes you've got to change the angle a little bit until you see that solder flow right around. You want it flowing around the lead a bit and the pad at the same time, so I think not up the lead or anything like that. But if you've got that little bit of heat from your tip pressing into the pad, the solder should suck around both parts at once because they're both slightly heated, and then the solder will just flow nicely like there. It's not working because I'm not on the pad properly, so I was just sort of butting it into a hot lead. It didn't really flow, but you will see it. You know, I'm a bit out of practice myself, especially with these little fine pads. These are very tiny little pads. Now it's going to move when I touch it, but yeah, just a matter of getting the angle right, and you should get it to flow around that lead nicely. And once you see it, you'll know what it's doing. You'll know when it's right because you'll see it just sort of fill out the whole of the pad. That little donut on the circuit board will just fill out nicely with solder. And that's about all the time you want to spend on a transistor. So I've done one lead. I'll see if I can get a closer up shot with a different lens and sort of show what I mean. But yeah, it's probably almost a bit of Vero board or something. You almost need to practice just soldering onto the pads themselves, just getting a little dome of solder on there and then going around a lead. But it's all the skill is in touching both the pad and the lead at the same time, just with the very tip of the soldering iron. So either the side or the end of the tip is pressing onto the copper, onto the circuit board, and the other bit's basically butting onto the, so you've got two faces touching, one down onto the board, second one into the lead. And as soon as once you get the feel of it, you'll get that exact contact with both. And as soon as you put, it just only needs 10 milliseconds, 20 milliseconds, it's part of a second really. You can immediately go in with the solder, and that heat will have already transferred into the lead a bit and into the pad. You don't want it transferring up the lead, just the immediate area, and just transferring into the pad quickly, because if you put too much heat in the pad, it will separate from the board. And as that solder comes in, you should see it flow round and just cover the whole pad, sort of mound up on the pad, and you know it's pretty right then. And of course, always place to check over. One of them I've got it up the lead a little bit there, it's a little messy. Once you get the hang of it, and this was a bit difficult on some of the attack angles because I've got so many components in here at once. So I was having to go in at all sorts of different angles. So there are a few blobs on the lead where I've touched the leads a bit, and you'll sometimes find that at the actual pad, instead of being a nice ball around like a couple of these, it starts wicking up the lead a bit and makes a funny sort of pointy Instead of a nice dome, it makes a bit of a pointy thing there. Yeah, most of these you get a little bit on the leads, but that's no big deal. Chop all them off. And just, yeah, check your joints as you go, check them after. Oops, we've got a little bit of solder. Don't know if that's fallen in there. I don't think I wicked that across here. It's fallen off something, so just make sure there's no solder between any of the joints. Make sure all the joints look like they've got a nice ball of solder right round the pad. So you don't want like a half pad or anything like that. And it should curve upwards to the leads themselves. So you've got it's all the way around the pad, and it also goes up to the lead in a nice little dome there. And even once I've cut them all off, I can still see that they should all be good joints. If it's moved, you've got a dry joint off and they'll look a bit sort of crystalline or dull. These have all got a beautiful shine on them, which is how they should be. Should be no, oops, I forgot to cut one off there. Should be nothing dull or anything like that. Oh, I've got a couple of leads stuck on my transistor for some reason. But yeah, these little kits are great because they've got the screen printing. A lot of the ones I built when I was a kid didn't have any screen printing, so you had to keep looking to the diagram, the board layouts. This one, well, it does actually have a board layout, so it does have one to cover. I was going to say it doesn't even have one, but it doesn't really need to tell you where the components go. But it always pays to double check, like your C1, your polarised electrolytic, make sure the negative's on the outside, positive towards the potentiometer, the trim pot. And just as you go, check all your diodes, even though since they're marked on the board it's a bit hard to get them wrong, but just double check all the bands. Any polarised parts are all in the right places. You can also check your resistors as you go. This is a good point about now to check them. And the 10k ones have like a brown, black, and then red for two zeros. So I guess it's 1 0 0, another 2 zeros, so 1 and 4 zeros, which is 10,000. Whereas these other ones are brown, black. So it's probably, what were they, 100 ohms I think they were. Yeah, 100s. So I guess that's 1 0 0 and then 0 further zeros is how these 4-band ones work. So that means, yeah, you basically read the first 3 digits and then there's nothing after that because it's 0 zeros. Whereas the other ones have got 2 zeros on top of the 100 that the brown black makes up. 1 0 0 and then another 2 zeros. So it always pays, just as you go, just check things how they should be. I mean, the transistors show which way around they go just from the screen printing, but doesn't have to check. They're both the same sort in this one, so I can't get them wrong. It doesn't matter which one goes in which hole, because what are they? They're actually 58050s or something, whatever they are. Some generic little transistor. Does it tell me what for the diodes are? 4148s or 1N914s as they used to be called, and then they went to 1N4148s, which I don't know what the difference is, but I think that might have been slightly higher voltage or something, or maybe they're just completely equivalent. Got 2 ICs. Where's our Q1, Q2? It's an 8050. What did it have on the front? 8050. So it's an 8050, whatever that is. No idea. There was all sorts of new transistors. I remember back in the old BC days, and all the Japanese were 2SCs and Ds and stuff, but they're all, and the old American ones were 2Ns, and there were some ancient sort of British and European ones were OCs and BCs, and the BCs were still available, but a lot of the quite old germanium transistors and stuff, a lot of discontinued stuff. These days they got all sorts of random numbers on them. But yeah, that's our parts. I'll see if I can do a close-up as I do these transistors, see if we can get an idea of seeing what the solder looks like when it flows. But the main thing, yeah, is like I say, remember you've got a little donut, some are square, some are round, but it should flow right around the whole thing. And it should also flow onto the lead in a little nice sort of dome. Not sure if they're convex, I guess they are sort of convex, or doesn't really matter, but as long as they flow up, sort of bead up around the lead itself and lift up to a point that is just the lead coming out of that point, then you know you've got a neat solder joint. But it is quite a bit of work to get the art of it, getting that heat in right, and then dabbing enough solder in and withdrawing it just at the right time so you don't get too much or too little. but you can sort of, yeah, if you get the heat right, then as the solder goes in, you'll kind of see the ball form. And you know, as soon as that ball's forming, I mean, a lot of the time you're probably already automatically withdrawing. But of course, with different pads, you need different amounts of solder. Sometimes you use thicker solder to achieve that. Sometimes you just got to push more of this in. But it's certainly an art form where you're getting feedback from your eyes and you just sort of, it's a mechanical motion, you know, roughly with these smaller pads, how much time, basically get the solder in the right angle to touch both things, and then dab it in and pull it out. You're sort of pulling it out automatically, and usually you'll get every joint pretty right. Okay, so I'm going to be soldering this transistor, which is these 3 leads here. I've already soldered the one at this, I guess, the top of the screen end. So I'll see if I can actually get a decent view of this. Very hard to get the focus exactly where you want it. So what I'll be doing is bringing this, see if we can focus on this soldering iron tip. You can see it's like a bit of a chisel shape there, and it's wider as I rotate it a bit. So it's got a couple of flat faces on it, so they can be used to my advantage. So I'll be coming in sideways usually, and like I say, be trying to hit the circuit board pad and that transistor leg at the same time to get it over and done with as quickly as possible. I've got my solder ready here, so it's basically in, we've got heat, put a bit of solder in, retract, and this one I'm going to have to come in the middle lead at a bit of a different angle. So again, I've got my little chisel, that's the chisel face facing upwards, so I'll rotate it, and then I'll come in on a bit of an angle. In this case it'll be facing me, so I can see a little bit better what I'm doing. And I'm inside, solder on. I probably should have tinned that tip a little bit more, so I had to give that a couple of goes. Now the question is, I think I've actually bridged that one, they're so close. So let's cut these leads off. Yeah, I've actually bridged the solder on that. That's the problem when you actually think about what you're doing, you actually do it worse than doing it automatically. So that, yeah, that's pretty well stuck. I'll have to get my solder sucker. Now there it is. Not something I use very often these days. And I'll suck both these off. I didn't get all of it, I don't think. It's probably clogged up a bit. But I'll redo those since I've took the solder off it. I should get rid of all these leads out of here. Try and keep the bench a bit clean. So here's another transistor at the other end of the board. See if I can get that around the middle. Now I've got a little bit of solder on my tip this time, which should, I'll just draw that off a bit. You want a little bit on there preferably, but not too much. And we'll come in from the back lead, middle lead, end lead. So I probably went not, because I was demonstrating, I went in a little bit too deep with the soldering iron, which is why I think that bridged. So in this case it was more a case of come in only as far as the lead itself. So I'm on the pad, as soon as I touch the lead a bit, then I'm in with the solder. That way there's no chance of, if I got the tip in too far and the solder on the front a bit, it'll probably bridge out a bit. So that's all looking good. No sign of any bridges there. The transistor's not quite straight, which is annoying, but it's not my best job. I should have really done one lead on the transistor and then probably checked it was straight again. But anyway, it's only a little practice kit thing, so not the end of the world. I can actually see this on the camera better than what I can see with my eyes. So the problem is with these sort of joints, sometimes it's hard to tell if there's solder between the pins or if it's just a bit of flux shining there. With these more modern boards, which are very fine. I actually noticed this when I looked on eBay at this thing. It said it was an SMD kit, as in surface mount device, but there's no surface mount in this thing, but it is good practice for very fine soldering. But you can always get the multimeter out if in doubt. Set it to continuity, and we'll just check across our pins. No short, no short, and same with the other transistor. Yeah, my eyes aren't as good at this as they used to be. So these little fine parts are getting a bit difficult for me to see now. And these fine little pads, when they're so close together, it's much like surface mount devices. I would normally have a little bit brighter light than what I've got on this bench. These are not ideal, but yeah, you get the idea. And it's all about the attack angle and stuff, so yeah, sometimes you just, I mean, I do it naturally when I'm actually thinking about it. I have more trouble with it than doing it naturally after years of practice, and you know, probably tens of thousands, hundreds of thousands of joints, I don't know, but a lot. So once you've done it that many times, you don't really think about it, it just comes naturally. But trying to learn it from scratch, it certainly took me a while to get good at soldering and not damaging. I used to destroy transistors and stuff from heating them up too much, whereas now I can just go pow pow pow, and you'd grab it, you'd barely feel any warmth on it at all. Now let's have a look if these LEDs, they want them a certain way or not. They're saying L1 to 12, it just says 5mm. I can't read Chinese, so I don't know which colour is which. Let's see, 1 to 12 is, I assume, one bank, is it? L3, L1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 years. So all colours on one thing. So now we've got to work out our LEDs. Now these always used to be, I think the long lead's the anode, the larger piece inside. So the anode's got the longer lead on it. Not all LEDs are like that, but they usually do. Sometimes they had a little mark on these bits on the cathode, I think, and rather than the anode, and the anode is usually the smaller piece of metal inside. So one way to always check or know which way an LED's around is that little bit with that little bowl in it, which has got the like a little reflector, and it's got this big piece of metal in it, which is part of the lead. And yeah, if you look in the front, you can't really see on these milky sort of ones rather than the clear ones, but there's a little reflector bulb thing there. It has the LED segment in it, and this other lead comes up, and there's a little fine wire in there that goes to the LED sitting in the other bit. And we should also have a flat face. You can just see that glinting there. The cathode should have that little flat bit on the rim, this little rim bit going around the LED. The rest of it's all round, and then you get to that little flat section, so it's even more proof. And the cathode, the flat being the flat on the diode symbol here, the arrow being the anode, and it's pointing to that big pin, and the flat bit on the LED. So all we've got to do is put a bunch of these in here. Now these don't even stop, so setting the height of them is another thing. I think for what I'm doing, I'll just set them to where those metal, which we can't see here because the focus range is so short, but where those little metal bits stick out, even though they're not stopping it going into the board, I think I'll set them about that height, so it's got a few millimetres. I mean, again, LEDs, you don't really want to solder them. You can solder them straight to the board so they sit in flush with the board, but again, you have to be a very quick solderer. Always better anything to have a little bit of lead length there. I guess with these, if I set a couple of them to the height I want, which is not going to be so easy, I'm probably going to have to solder it in while it's on its side, because if I put that on the front, it's probably going to slide in. I might just set it so those metal bits are just at the hole, and set a couple of them to the same height, and then we can sort of sit it on something and get all the others to just drop, I guess, to the same sort of height as the first ones we do. So I've got one lead soldered in, that's what I want it, straighten it, get it at right angles with the board basically, and maybe do the other corner. Again, always checking short lead, flat bit, and that goes to the line on the LED, the diode diagram. And yeah, we'll get those bits lined up. This is probably going to be the longest part of this project, is getting all these LEDs in and just again making sure they're straight. And they should be about the same height. I'm not sure they actually are, surprisingly. One looks a bit longer than the other, but maybe that's just, no, I think they're alright. So what I'll do is here, straighten them, and without putting any pressure on them, without sitting them on the desk or anything, I'll just solder the other second lead. nearly get my finger in the process. So we've got those, they should be about the same height where those metal bits butt into the board. I think once the couple are there we can just put all the others in and hopefully just sit them on something solid. Might just use one of these plastic containers and I should be able to get all the others, although I won't put too many in at once I don't think. I'll just solder them off as I put a few in. Sit them about the right height, maybe even a bit longer. And again, making sure with everyone I've got the polarity right. Get in there. I can't even see the holes on this board. Oh, there it is. It's inside the little circle. That's why. I'm thinking it's outside. So if I hold them flat and then just push those LEDs down onto a surface, I guess what I should have done is actually even better. I think I'll put a couple of the blue ones in so that the whole board is sitting evenly. Of course the blue ones look like the marks on the leads are a little bit different height. I probably should use something to get them perfect. Use something to measure them and set them right so they're all identical, but rather than the actual... Yeah, so now I've got this one in, but I just want to adjust it a bit so I can just melt that solder again and just, whoops, I pushed up, but then I let go and it fell back down. Yeah, that's it, that's perfect. And another blue one. Now I did get that the right way around, didn't I? So there's all these little things you've got to remember, getting everything, you're trying to get the height right, but you've also got to make sure the polarity's right and get at least one lead soldered off. I think that one's a little low, but anyway, that'll... Now we should have a board that sits... I'll readjust the focus a bit. But I've got that sitting on a little plastic container now. Got four LEDs in, 2 on each side. So now any LEDs I poke in, again making sure that it's a short lead, flat bit on it. I'll put another, say, 2 in. Maybe I might go 3 actually. I'll put 3 in the one, finish one row off. Turn it upside down, sit it on the case, make sure they're all fallen down. And then again we can get our soldering iron in here. Trying to hold the board still, they're going to bend the other way probably, but just touch the 2 bits, soldered. Touch the 2 bits, soldered. Touch the 2 bits, in with the solder, so I'm just touching, sitting on the board pad, butting the chisel face into the LED lead. And it doesn't have to be perfect, the angles and stuff, but you just got to kind of know that you've got that contact. And you know, there's some nice little perfect connections. The LEDs wouldn't have felt any heat out of that. To make life easy, I'll start chopping these leads off, so I don't have a forest of things to navigate in. And yeah, so we've got 1 row and 1 LED. They probably need a little bit bending here and there, so that one's actually tilted back a bit, which shouldn't have really happened while it was there, so I'll just have to loosen the solder, and just if that pulls back anywhere, you just need to make sure it's touching the pad right round, or the donut. Yeah, it's still slightly out, but they can be sorted out a bit better later. You might just have to jiggle a couple around. That's the problem without having some sort of nice grid to put them in. But I'll keep progressing with that now, just following the same pattern. I'll maybe film a few more of those solder joints. Okay, I'll try a few more LEDs with the camera with some bit more light on it. That seems to work reasonably well, if the focus holds alright. So I'm basically coming in from the opposite side with the solder, basically jamming the soldering iron tip into the pad and the leg at the same time. So I'm down flat on the board, chisel onto the lead, and solder in and straight off again. Sometimes that means a little bit of solder gets flicked on the lead, but at least I'm not there for long, so I'm not putting any heat into the LEDs. These are probably a little bit out, but I can bend them sideways, no problem. They're not too bad height-wise. That one's tilted a little bit, so I can chop these leads off. That'll still give me enough lead to get one of them straight, which is a little bit out. That's all it needed, a little flick up. Now all the LEDs on one side all seem to be facing the same way, these red ones. Well, I've used red on this side. Over on the 4017 side, they're all facing the same way. But on the other side they've done something a bit different with the tracks here. I guess because they're 3 per row, so they've wired them up differently. I think this might be the 3 per row side by the look of it. So what they've done, if you look, there's a couple here that are actually backwards. I mean, that one's, you can't really see the diagram, but it's facing this way, so it's facing towards the trim pot there, or that label, whereas all the others are facing to the other side to where the transistor is. So you just have to make sure a couple of those you put in. I might actually do that other one next. So the short lead with the flat bit and the large piece inside the LED. And sit it on the flat plastic to get the height right. And there's that one right in the middle there. Again, come in with the chisel point. There it is, off to one side. And I'll just slide that in there, touching the circuit board pad just with the edge of the tip, and the chisel up against the lead just for a second. Well, not even a second, but it probably is around a second, I guess, by the time I get the solder in. And that's those two joints done. Get rid of that. So those two LEDs are facing the other way. I'll just double check flats to where the flat is showing and the line on the diagram. So the rest of these I can just shove in all the same way. But that's something to watch on this kit. Not a very good design when they do that, but it's probably just made their circuit board trace layout a bit easier. But yeah, good design feature is to make everything the same so the constructor can't put anything in the wrong way. Not that it's probably a big deal if you get a couple of LEDs in the wrong way. About all that'll happen is they won't light up. And here's our next row of LEDs. Yeah, that one I thought was sitting a little high. Just make sure they're all sitting where they should be. And you can use a circuit board holder or something. I don't normally bother because I'm a bit of a slacker like that, but I just grew up building them basically like this. But you can get those clamp type things to hold the circuit board still while you're working on it. Certainly when you're starting out, it's not a bad idea to have something like that, or you can just hold it with your hands a bit just to steady it. Oops, I think I just bridged that by melting one lead and straightening the LED, but it's always best to just redo those joints if you fiddle with them, because chances are you might have made one of the joints a little dry, or you may have bridged it or something. Always check any joints you mess around with, because you're moving the part, you may well fracture the solder before it's set while it's in its liquid state, and that means you could get a dry joint. Not the end of the world with a kit like this, but still better to avoid it if you can. Get the last two in that row. Oops, one's fallen out already. They're quite a tight fit, so they do tend to hold themselves in place, but without having to bend the leads apart. So I'll get in again and just see the same process on the pad, on the track. Whoops, I'm on the wrong. What have I done there? Why is there another pad there? Yeah, don't know, they've just got a hole in the board. That threw me a bit, but I am in the right holes. So I'm not sure, there's a couple of spare pads. That's hooked to an LED, so there must be another component. What have they done there? I don't know what they've... Or is that actually... Oh, it must be joined, that track. I thought it wasn't joined to the next one, so that's just when you cut these bits of circuit board off. That didn't quite go to the corner of the pad, so I'll just redo that one. But again, slide into the pad and the LED lead. So that moved a bit, so it's probably not going to be straight. and then apply your solder. And if you're doing it sort of away from you, you should be able to see it flow right around the donut there, right around the pad, right around the lead. I bet that one's going to be out a little bit. Whoops. Oh, they're only tilted sideways, so that didn't sound too good. And my Chinese LEDs aren't cracking already. You never know. Probably not made out of the best plastic, these things. I mean, I don't know how they do the kit so cheap, so... Ooh, something doesn't... I haven't broken the board. No, it seems alright. I swear that's moving more than it should. Oops. Ooh, something good's not going on here. Good, I think I've actually broken the circuit board track already. So what is going on there? Yeah, it has. It's... Geez, they're flimsy. So these circuit boards aren't very well... Copper isn't very thin or not very well attached. So where am I? I'm on these two pads here. Just bumping that lead a little bit. You can see that pad here in the middle of my fingernail is moving around. And if I wobble the next LED, that one's moving around. So that means they've basically, that little bit of track there is broken. That's certainly very weak. You should be able to move these LEDs like side to side at least. But again, it is super cheap, this kit, so we can't expect too much. So what I'll have to do is just get one of these little cut off bits of leg, and we'll just solder that between those two. Bridge out that bit of track. We'll have to cut it a little bit shorter. Push it onto the other pad. It'll probably try and unsolder itself from the one I've already done. Yeah, just drop that one down a bit. Again, this is a bit of an art to learn because you're moving things, so you're probably not making the best joints in history. So just give them a re-solder. Make sure you see it flow around the little wire bridge there. Yeah, that'll be fine. They're both moving together, but they've got a piece of metal to join them now, so there's a little trick to fix that. But yeah, it's amazing. I've barely touched that LED and it's, well, both of them, and it's popped the board off the track off the board. But we can't expect too much from this. I guess they didn't make it this cheap out of top quality stuff. But yeah, it's pretty rare. Normally you'd have to put a fair bit of force to break a copper track off a PCB or actually overheat it like anything. So I'm going to make the last row of red LEDs. I'll just push all them down. Make sure they're all right seated down on the plastic thing I've got this board on. That's something to watch. Just be super careful with the LEDs by the look of it, or they'll break. That's that one. Yeah, I'm not making the best contact sometimes, so sometimes you've got to flow a little bit of solder in just to, even though you've got the heat on both things, that's better. A little hard to see what I'm doing with such fine pads. And there she goes. But if you're sort of off to one side, I'm left-handed, so obviously I'm on the left-hand side. But if you can get sort of around the back of it a bit, and to one side of it compared to where you're sitting, then you should be able to get a good view of that solder flowing. And that's all the red ones in. A couple of those are not straight either, but I don't feel like bending them now. They should bend sideways pretty safely. It's just if you've got to move them, like that one needs moving back the other way a bit, so that's when you definitely make sure you melt the solder before you push on it. Maybe that's what I didn't do enough of. Could have been why it broke, but I thought I did it sideways and it broke. But anyway, so they're not exactly perfectly fitting. Ideally these LEDs want a little grid of some sort to get them all centered correctly, so they're held in place when you're soldering them. But anyway, that'll do for a little demo board, a little practice board. Put the last row of blue ones in. Oops, now I got that the wrong way around. Long lead is the anode. short one to the line side. Wouldn't be surprised if I still got something wrong here, but they should all be right. Like I say, with LEDs in this sort of circuit, they're not going to blow or anything, or do any damage to the chips or anything. If you get them the wrong way around, they just won't conduct at all. So it's not the end of the world. Try and keep this in shot. I always forget to move everything so it's in shot. So I'm the only one seeing it, but the problem is you tend to have to move things a bit closer to your eyes so you can see what you're doing. Now I'll chop all those off. Probably should be tossing these in the bin. I tend to throw them all over the bench just because it's convenient, and then clean up the mess afterwards. But everyone should find their own way of doing things. You definitely don't want these anywhere under anything you're working on, because of course bits of metal can conduct electricity and you don't want them shorting out under your circuit board or something, so we'll clean them up after. But it doesn't matter if we make a bit of mess while we're working, as long as you don't connect the thing up sitting on any of those bits of metal. Could come in a little bit more, and that I probably went a little bit too far. I tend to blow on the joints sometimes a little bit to speed them up so that the solder goes hard quicker, which can help. Ooh, stabbing at me. Got to be careful with these things. Probably should use a vacuum cleaner really, but these LED leads in particular, the square ones, are pretty nasty. They're very sharp. Get rid of the worst of those. Okay, so all we've got left here is the bit of wire, which I guess I might as well put on. I could have made it black and red to match positive and negative, but they've given me an orange and yellow of all things. So another thing that's good to practice on is soldering wires, that is tinning them. So you strip them, you wrap up all the strands using your fingers, rotating whichever way suits. I think different people go clockwise and anti-clockwise, probably depends which hand you use. But then again, we use the chisel face basically, and I usually apply a bit of heat to the solder, and that's usually enough to get it going on there, but you can put the heat the ideal way. Put your soldering iron with a bit of solder on it under the wire, and then drop the solder in from above and run along the length a bit. Don't worry about the ends too much, because you cut them off usually. A bit messy towards the ends there, so we just solder those bits, cut them off. I guess I'll make the orange the positive, since it's closer to red than yellow, just by a little bit. And we've got our wire through a couple of points here. It's just holding itself in place under the board, and that's the wire attached to the positive. It says VCC, but it goes to the biggest pad there, but maybe that's just because of the way they've etched the board. I think the transistors were connected to ground anyway, which is here the other side. So we don't need to worry about that. Now we can get our little chips. There's our 555. We'll put that one in first, because that's just a linear chip. It's not too fussed about static electricity or something. Obviously you don't want any major static on it, but just normal handling shouldn't worry it, unless you're wearing some very plasticky bit of clothing. So now we just do the two corners, double check that it's sitting flush there. May want to press on it a little bit, and that it dropped it just ever so slightly. Not that it really matters. Again, obviously checking pin 1, you've got that little mark on the end of the chip, which is also on the screen print. Usually the writing also will be up the top, sort of the one down the bottom. Sometimes they have a little round circle, little indent in them to mark pin 1 as well. but that seems to have gone by the wayside a bit now. And again, you want to spend the absolute minimum time on each pin. If you do spend a bit too long, if you're a slow solderer, then just do one pin and then give it a few seconds to cool before you do the next one. But yeah, I can't feel any warmth in that chip, maybe just the slightest bit, but it's not really noticeable. If you start putting your hand on there and it's quite warm or even hot, then there's a chance you'll cook that chip. So try not to get them that hot. Focus seems to have got a bit out here. Unfortunately not a lot of depth on it either, so that doesn't help. Let's see if I can find my IC insertion tool. Found him. Okay, so this is a 14 and 16 pin. It's just basically a metal U shape with a handle on it, and then you've got a little plunger here which pushes that bit, so you can, probably should move the camera back, but you basically just sit the tool over the chip in this foam. You can actually push in a bit and the chip should come out inserted into it. All the pins are shorted together by the metal, which is great, so there's no chance of static electricity. They're all at the same potential. Now the one mistake I made is I've forgotten which end is pin 1, but I can see an indent in that end, so I'm assuming that's pin 1. And we can simply go to our circuit board. The tool hovers over. You can also see with all the pins, they should bend them slightly inwards to match the holes in the circuit board and make sure they're all straight. It's actually a little wider than this circuit board, so I can press down on the plastic now. I'll push that in a little bit deeper to get those pins, yeah, just exact the right width, and then I press down on the tool, which no one can see, but you just then press your plunger bit in and push the chip. Once you've get one row of pins in and then straighten it, and if the chip's pushed right deep into this thing, it should match the holes perfectly. Again, double check, we've definitely got the indent at one end, and the writing relative to that, reading across from pin 1 sort of thing. So that's in the board. Whether this thing has survived its trip from China in a plastic bag in the post, I have no idea, but I'll just get that focus right again. Always go the wrong way. That should just about do it. So again, I think these chips got pin 1, I think it's pin 1 and 8, or is it the other way around? Pin 16 maybe. I know CMOS chips you're meant to do, might be 8 and 16, you meant 2 at the end, yeah, because they look like they're the rails. Yeah, the other one's not even connected there. I think you do pin 8 and 16 because there's some sort of diodes inside them, there's some sort of static discharge protection thing. So definitely best, yeah, to do those power rail. I think they're the ones, because this one, the other pin isn't even connected, which must be pin 7 I guess. Or pin 1, yeah, pin 7 it must be. Oh, sorry, how many pins are on this? Is 8. So maybe it is the other way. Pin 8 isn't connected in this one. Where are we? That's 16. That's 8. This is pin 9. Pin 9's one's not even connected to a pad there. Oh, that one, I haven't quite. There's a solder pad just here that you can see. You can still see a little bit of the hole on one side. It's not connected to anything anyway, so it doesn't really matter if I have a dry joint there. Yeah, for some reason they left one pin without even a pad, which doesn't really matter. You don't have to have a pad on the pins that aren't connected. So that's it. That's everything assembled. I guess we should just go over and double check. Chips are facing pin 1 towards the transistors. The transistor faces that way, that way. Electrolytic capacitor has its negative on that side. The diodes point outwards, the diodes point outwards. Our LEDs will soon find out if they're connected or not. So that's all we really need to do. I wonder how many volts this thing's meant to run off. It's CMOS, so it shouldn't matter too much, shouldn't be too picky. Doesn't say anywhere, but it should be, I forget what the range of CMOS is, but anywhere from 5 volts up to, I don't know, 16 or something, is it? don't quote me on that, but a 12 volt should be safe. I might go for 9 volts just to be sure, but these LEDs would have been rated, the resistors that run them would have been rated to run off a particular voltage to give the best brightness, I guess. But I'm not quite sure what that is, so just strip these other ends of these wires off. I might give them a quick tin as well. So again, you can, if you've got a bit of wire, you can spend all day practicing tinning this stuff. So yeah, soldering iron on one side with a chisel and solder on the other. It's not too picky. You can sometimes just tin them with a bit of solder on the fresh solder on the iron. I shouldn't have cut that so short because I want to get my clip leads on that, and they're not very good at. I'll just turn the voltage down a bit. And I better set this camera, I guess, so I can actually see what's happening. There's the circuit. That's definitely ground on the yellow, and here goes nothing. Well, we've got some LEDs out by the look of it, so maybe well, that's what it does. Except, yeah, I've probably got one in reverse there somewhere because that whole chain is out, or is one. I don't know if that's the chain or not, but it's certainly not an LED chaser. It's an LED flasher of some fancy sort. But it goes to show, even on a simple kit like this, you can get something wrong. Let's disconnect the power. That LED's in right, unless one of those, oh well, that's the one that track broke on, I think. Oh no, that's the one next to it. So they're all facing the same way. And they all look, let's see if I can see the metal bits inside. That's the flat bit. I can't tell if the metal's actually big on that side or not, that's a bit hard to tell. And it could be a faulty LED as well. Or it could be that I have broken another track here somewhere. Oh yeah, there we go. See if we get that focus about right. We've definitely got a wobbly track. It's that one next to the other broken track, I think. There's a pad here. There it is. Look at that. One in the middle of my fingernail again is wobbling. So yeah, so fiddling around with these LEDs there's a problem with this kit. It's very easy to break the circuit board tracks on this, the pads off the track. So this, I think this bit of LED lead's already tinned on one end where I've cut it off, where I've soldered it, but just tin the end. Well, at least I didn't put a part in backwards, I feel better about that. Put that under one, let that set, and then what we'll do is we'll melt that again and move it across a bit. Oh, it's actually moved the other way, which isn't too good. It's not going to short, I don't think, but ideally you don't want it moving towards the other pad. Put that in. I probably should have cut that first, actually, like I did with the other one. But I can still get my cutters in there, I think. Just, problem is I might put a bit much force on. We don't want to break something else. So there we have it, two linked over bits, which should get our kit going. That was definitely positive on that, yep. Don't want to blow it up at this stage. Well, so much for that theory. Still got LEDs out. Well, surely the other side isn't broken as well. I might fit the multimeter onto this. It's always the best way. So that's, I think, a different, yeah, those three are in a chain together, I think. So if we touch on the lead there, they should definitely be shorted. Yeah, no, we've broken another track here. So that's a definite weakness in this kit. And that was just me trying to straighten the LEDs up because they were slightly out. and I made sure that I melted them before I moved them in the sort of in line with the leads, but it's when I actually moved them side to side I think it was enough to break it, which that shouldn't really be enough, but I guess if the LED leads are hard enough. Let's push that back over. Basically repeat what we did. Now it's stuck to my soldering iron tip as it does. I'll put it down this side then. It's a problem, they're magnetic as well often, steel leads. You really need to hold it with something. Yeah, that's it's sticking out a bit, but I've got the solder bridge to it. Doesn't want to cut off now. Not that really matters, but I might as well try and get rid of it. There we go. So there you go, these boards are very weak. Okay, let's try it out. I haven't bridged anything. Probably should resolder those joints in a way to make sure, but to make sure they're ultra reliable. Oh, I finally got all blue LEDs lit in our supposed chaser. So looking at the circuit, I thought it was going to be something like this. It's just those diodes feed from the outputs of the chip, and it just feeds these LED banks rather than individual LEDs. With a bit of work you could probably modify this to make an actual chaser, so I don't know what this is meant to represent, blue and red flashing. Or if there's any particular, maybe the sequence doesn't look exactly perfectly symmetrical. 1, 2, 3, 1, 2, 3, 1, 2, then it suddenly jumps. 3, 1, 2, 3, jump. No, it is the same, so we're using 6 outputs by the look of it. Yeah, there's no decent delay between them. Sides seem to jump quicker than the flashes in between. Maybe it's just my imagination, but anyway, that's this useless little circuit built, and surprisingly the chips all survived and everything in place, so that's not bad for $5, even if the circuit board's a little on the weak side. Now I guess the other thing we should never resist doing is tweaking our pot to see if we can speed this up. Oh yeah, here we go. That's faster. Oh god. So it's kind of like a little emergency beacon or something. Let's go down to minimum. Very slow. But yeah, if you're thinking this was an LED chaser or a surface mount device kit, you'd be pretty disappointed, but you can certainly see in the advert that it wasn't any sort of surface mount kit. And I had my doubts whether it was a chaser or not, the way it looked like the circuit board had two batches of LEDs. So that's not a chaser. And once I saw the circuit when it arrived, yeah, I knew for sure it wasn't a chaser. Well, I guess it chases from one side to the other side occasionally, so technically it meets the consumer laws. Yeah, so, oh well. Doesn't look quite as good in the camera. The blues look a bit washed out, but it is pretty blue to the eye. And this is standard red LEDs, nothing super bright or anything here, just really basic ones, but still better than the first blue LED I ever purchased, which cost me $5, and you could hardly see it at all, but that was when they first came out, somewhere around the mid-90s I think it was. Must dig it out and have a look sometime. I think I've still got it somewhere. Yeah, it's something a bit more exciting when it's faster. I guess you wouldn't really want it any faster than that. Almost like some flashing lights on a helicopter or something. Give that sort of fast strobing effect. But anyway, that's got it all going. And like I say, it's a good little practice, soldering practice sort of kit. I don't know how many joints that is, I guess I could count them, but quite a few solder joints there to do, and a little bit of fault finding where the pads broke off the board. And yeah, these actual boards can be cut or snapped even where all these drill holes are, and you could remotely mount these LED panel bits, but you'd certainly want to try and, you know, I didn't spend too much effort, I just basically set them to get them all about the same height, and I must admit height wise I've got them near nailed it, pretty perfect, but they certainly aren't quite as well spaced the other way, and now I'm a bit afraid to bend them in case the board breaks again. That one there definitely wants bringing backwards a little bit, so melting either lead and pushing on it should get one to rise or one to fall and go in the direction you want. But yeah, an interesting little project, and yeah, certainly a lot cheaper than what I used to be able to buy little kits for, and I do like the screen printing on it. It means it's almost foolproof, you don't have to read the instructions all the time or where everything goes. Everything's got a part number like D, so you know it's a diode, R for resistor, the standard thing, and even the cathode's marked and things like that, which holes they go between. Pretty foolproof. And yeah, even though it's just posted in an envelope, the chip survived alright. I don't know if I can measure that. I don't know if a multimeter will work on the ohms range, but certainly I think static bags you could measure something on them, but is there a little bit there when I get really close, or am I just touching the probes? No, I don't. If it is a static bag, it's not a very good one. But anyway, it survived. Oh, I just realised I've got a spare LED here. Looks like they gave me a free extra one. Oh well. There you go, a whole 1 cent LED or something for free. So that was a little extra bonus. I guess maybe that's in case you break one. They probably just counted them wrong. Although these things are normally weighed out and super fast processed these days. But who knows, these could be hand assembled or anything, we wouldn't know. That's how they used to do them in Australia, the old Dick Smith ones, and then I think were all hand picked parts and packaged up. But yeah, anyway, that's a good little, if you're looking for a little project to practice soldering on a few different components, you could always just get a piece of Vero board or something and solder wire links to it, which would be highly boring, but would get you plenty of practice. Or, you know, buy a few of these little things, and there's nothing like actually building something. I mean, if it was just for solder practice, yeah, you might just use some Vero board and you could get some cheap parts, resistors, or just, like I say, just wire links bent over will do the job, and just get your practice in that way. But at least with a kit, if you actually build something, then even like with this one, you might find some faults with it or something, and that's how you learn. Nothing like getting in and making a few mistakes, putting in a few parts the wrong way or something, and then having a fault find or bridging a joint or making a bad solder joint. That's always the best way to learn these things. And yeah, that's a completely useless product besides that, but something fun to play around with. I haven't built a kit, I can't remember. I think my ESR meter was the last thing I built, and that would have been, I don't even know when that kit came out, but it'd be 20 years ago probably. I don't think I've even built a kit since then. I really doubt that I would have, and that's, yeah, certainly seen better days. I don't think they had a date on that thing. It might have an Electronics Australia. It's certainly seen better days. Does it have a date? 96 ESR1. God, it might even be that old. Dick Smith ZA1245 kit. I think I did build this around the time it came out. So the kit was done sometime in 1996 by the look of it, if it's got 96 in the code. So it might actually be first kit I built since 1996. I really don't think I've built anything since that. I can't think what I would have built other than a few bits of test gear I built before the ESR. I think that was the last. Yeah, I honestly can't think of another kit I've built since then. So that's been a bit of fun, a bit of going back to the old days and playing around. At least I can solder a lot better than I used to, and Certainly easy to find faults and stuff because I know exactly what I'm looking for, because that's the sort of thing you'd repair in consumer gear occasionally. Broken pads like that, where some bit of force had bent something, someone had dropped something or whatever, and you'd get pads broken off. Sometimes you'd just get boards where something had been hot and the pad would break off when you solder it or something, or you touch the component. Same as these, you bend something and the next minute the pad's busted off the board because it's detached from heat. Yeah, anyway, thanks for watching that one.